Now let's have a look at a few examples of how to evaluate limits of different types of functions. Now remember, the easiest way for you would be to graph the function and then check whether the left hand limit and the right hand limit is equal to the same and a finite real number. However, as you might notice, sometimes we do not have the time to graph the entire function. So how do we evaluate limits in these situations? The first example I'm going to talk about is this. Evaluate the limit as x tends to 1 of the function x square minus 3x plus 16. Now, the first step would be for you to put x equal to 1 into the function. So, putting x equal to 1, we'll get 1 square minus 3 into 1 plus 16, which is equal to 1 minus 3 plus 16, which is equal to 15. Which is equal to 14. So, if you are ever asked to evaluate limit x tends to a for any function, your first step would be to put x equals to a in the function f of x. If f of a is a real finite number, then limit x tends to a f of x will be equal to f of a. In this relation, here are a few rules of limits that can help us solve and evaluate limits more easily. The first rule is that limit x tends to a constant function, would be equal to the constant itself. Here k represents the constant. The second rule is limit x tends to a, x to the power n is equal to a to the power n. Third rule, if you have to find limit x tends to a k times f of x, you can always take the constant outside the limit symbol. The second rule is that if you have an addition or a subtraction of two functions of x and you need to find the limit x tends to a of this combination, you can always split it up as limit x tends to a f of x plus or minus limit x tends to a g of x. Similarly, if you have to find limit x tends to a of the product of two functions of x, you can find limit x tends to a f of x into limit x tends to a g of x. The next rule deals with the ratio of two functions of x. Limit x tends to a f of x divided by g of x can be evaluated as limit x tends to a f of x divided by limit x tends to a g of x, where limit x tends to a, g of x is not equal to 0. This condition, this exception condition, is made so as to ensure that your ratio is well defined and not indeterminate. Finally, the seventh rule says if you have limit x tends to a function of x raised to the power n, whole raised to the power n, that will be the same as the limit of the function at x tending towards a whole raised to the power n, where n is a positive number. And just to point out, here also in the second rule also we give the condition where n is greater than 0.